Alright, so we are moving on to our next shape when we're learning our 2D figures here, and it's a parallelogram. And what's really cool about a parallelogram is it is basically a rectangle that someone kicked on the top and made it sort of slanted. Because remember what a rectangle is, it's just simply a four-sided figure. And a rectangle has four right angles, but if you notice here, it's very similar to our parallelogram over here. The only thing is it's been kicked to the side, so now our sides are slanted like this, and they're not straight up and down. But what's super cool about them, though, is that finding the area for a rectangle, which is area equals the base times height, is the same exact formula that you're going to use for a parallelogram. Kind of cool, huh? Alright, so let's just make sure we understand what parallelogram is. It is a four-sided figure, and I have it pictured over here. It has two sets of parallel lines, and just as a reminder from 4th grade, parallel lines mean lines that never, ever, ever meet. So if you were to extend the lines on the top and bottom, or the bases of that figure, if you extended them out like this, and you extended that out like that, guess what would happen? They would never cross. Okay? So that's really important to know because this figure has two sets of those. So you see the blue lines. Now let's draw in some pink lines. If you were to extend the other sides all the way out and made them lines, they would never cross. So that's what makes a parallelogram. That's how it gets its name, because it has two sets of parallel lines, and thus the name parallelogram. Alright, so let's get started right away. The example in the book is they've got a pattern that's a parallelogram pattern. So we're going to draw it here. And they've got it labeled as 6. They have this labeled as 4. And then they have this labeled as 3. Alright, now, if you can't remember what the area of a parallelogram is, you can always go to your FCAT reference sheet because it's right on there. But you're going to remember because it's the same formula as a rectangle. Now, just another review thing here. If down on the bottom here, we know that this is our base. It's always the one on the bottom. But what is the length of this line up here? It has to match. So this could also be considered our base. So you could use either one of those numbers because they're the same. Just like the slanted line over here, this side is going to be congruent to this side, meaning equal to that side. So that's 4. So I could easily find the perimeter if I wanted to of this figure. I'd simply add the sides up, 6 plus 4 plus 6 plus 4, and my perimeter would easily be calculated at 20. Okay, but that's not what we want to find. We want to find how many squares can fit inside this figure. And so therefore, we're going to use our area equals our base times height. And I'm sure that you can figure out what B is here. So we're going to just simply substitute 6. We're trying to find area, so that stayed the same. We'll bring down our equal sign. And then here's where we get into the tricky part. What do we put in for H? Is H 4 or is H the special number that we see here that they gave to us? It is indeed that special number of 3. Because if you remember, we talked about parallel lines just a few minutes ago. The opposite of those are what we call perpendicular lines. These are lines that are perpendicular to each other. They make, when they are put together, they make a perfect 90-degree angle, and that's what that little box means. And that also means that it's our height. And I want you to think of your doctor's office. So here's you at the doctor's office. You're standing there. You're waiting to get measured, okay? And he has you stand straight up and down. Have you ever been in the doctor's office where you have been measured at a slant? No. So the slant line is not the line you're ever going to use for height. So think of the doctor's office when you're trying to remember, well, do I go with 4 or do I go with 3? You go with 3 because 3 is straight up and down. Alright, so now that I have figured out which number is my height, I'm going to simply just do the math of 6 times 3 because I know my times tables. That's 18. And then it's, of course, units. I didn't give any units in this problem, but it'd be units squared. And up here on our perimeter, it'd just be simply units. Alright, so pretty basic, almost exactly like rectangle. We're going to use one more example, and then this video will be done. All right, here is another example. Now look at this one. This one's kind of strange looking because I don't know if you noticed, but the height was not put inside the figure. It was actually drawn on the outside. And that's okay, they can do that. So again, you want to look for the straight up and down line when you're plugging in for height. But before we do that, let's go ahead and remember what is our formula. Oh, there it is. Or if we can't remember, it's on the FCAT reference sheet. It is area equals, now let's go ahead and make this feet so we have some units. Area equals base times height. All right, our base here is 7. And our height, is our height 27 or is our height 24? You want a hint? It's the one that's going straight up and down. Remember, if you're at the doctor's office, height is straight up and down. Look for the 90-degree angle right here. Okay, so we're going to use 27. And if we do the math on that, that's going to be 9. I'm going to carry 4, so that's 14,189. And then it's feet squared. So 189 little squares are going to fit inside this 7 by 27 parallelogram. And that is really all parallelograms are. So you just got to look for the height, look for the one that's straight up and down or perpendicular to the base, and then you don't want to use the slant. The only time you're going to use the slant is when you're trying to calculate the perimeter. All right, answer the questions, take the notes, and you should be set for parallelograms.